No, I'm not saying now. I wanted to say something to make sure I did.
For a final project in robotics class offered at Walla Walla University, our team decided to try and control a robot in real time using nothing but hand gestures. To accomplish this task, we used an Xbox 360 Kinect, a computer running MATLAB 2015A, and a Motoman MH5L robot. There were 3 distinct tasks that we needed to accomplish in order to make this work. First, we must gather the visual data from the Kinect. That tells us where the person is controlling the robot is commanding the robot to go. This was accomplished using the Kinect's built-in skeleton tracking hardware and MATLAB 2015A's Kinect interface software. We determined that the person controlling the robot would control the robot's motion with the right hand, control the gripper with the left hand, and use both hands to signal the robot to stop and return to the home position. Secondly, we needed to write a program that could take the position data from the Kinect and turn it into position data to send to the robot. This was accomplished using MATLAB, and code was written that could take only the data from the hands and compare it to the body of the user to produce a relative scale for the robot. This allows any user to stand anywhere in the frame and have a comfortable range of motion to control the full extent of the robot. The program also puts limits on the output coordinates of the robot to prevent the user from colliding the robot with the table or moving the robot outside a predetermined safe zone of operation. The final step was to send the coordinates of motion and gripper status to the robot and have it move. This was accomplished using a network interface supplied by Motoman. In addition to the motion, a gripper was designed using household items that could pick up almost any object using vacuum suction and particle jamming. Particle jamming is a phenomenon that allows particles held in a flexible membrane to be malleable under normal conditions. However, once a vacuum is applied to the sac, the particles will hold in whatever position they are currently in. This allows the gripper to pick up almost any object that can fit under the membrane. Overall, the project was successful. However, there are still improvements to be made. The Kinect and computer were able to process new input data at about 20 frames per second. However, the manufacturer-supplied interface could not allow these commands to be constantly streamed to the robot. This was probably the one problem that kept the robot from being 10 times faster and more accurate. The robot would have to move to a commanded point before it could accept a new command, causing lag in the entire system. Unfortunately, there was nothing we could do about this in the time given. In our final iteration, we were able to move the robot where desired and manipulate objects in its work area. This met the goal we had set out to achieve with this project and was very fulfilling and educational.